Welcome to Research Spark YouTube channel. I am Dr. Veer Chandra and I'm going to discuss the signal processing course here. So right now we are running in the unit first, the classification of signal and systems. Here is the outline of our discussion. We'll see the various operations on the signals, which includes the time shifting, time reversal, time scaling, amplitude scaling, and lastly we'll also look into the signal addition and signal multiplication. So let's start from the time shifting. So we can shift a graph in the two direction, either in the positive direction or either in the negative direction. So if we are shifting in the right direction, that is in the positive direction, then it can be expressed by x of t minus t dot. Question is, why is it so? So since we are shifting by some amount, as for example we are considering here the t naught amount, it may be the any number like 1, 2, 3. So since t minus t naught will equal to 0, then the t will be equal to t naught. So that is why this is shifting in the positive direction, as you can see in the graph in the image. Similarly, if we are shifting in the left direction, that is in the negative direction, then the expression will be represented by x of t plus t naught. Here, if you will make it t plus t naught equal to 0, then you will get the t is equal to minus of t naught. So that is why its origin will be at minus of t naught. So similarly, you can shift and find out the origin by making simply the time domain is equal to 0. So major thing is to find out the origin of the shifted graph. Then the next thing is the time reversal. So for any signal, the time reversal version is simply represented by x of minus t. So instead of t, just add a minus term along with the t, simply it will becomes the time reversal. In the graph, how will we get it? So just take the mirror image along the y-axis, we'll get the time reverse of any particular signal. As for example, in the first graph, xt is reversed along the y-axis, and you can see both of them are the mirror image to each other. Another example, for every points of xt at time t is mirrored to the minus t here. So another example is here, you can check that again we'll have the time mirror image along the y-axis. So whichever is in the negative direction, means left to the y-axis, they shifted to the right of the y-axis, and the signals which are in the right of this y-axis, they shifted in the left side of the same y-axis, just the mirror image to each other. So this is the example of the time reversal. Next thing is the time scaling. So here first image you can see this is the original signal, that is the xt. Now if you wanted to scale in the time domain, then we can just here example we are considering the a. A is the scaling quantity which can be the any number. Suppose if it is greater than 1, then the signal will compressed in the time. So you can see the image number 2, which is the scaling. The condition is that a must be greater than 1. So here x of 2t. So 2 is higher than 1. So the signal has compressed by the factor 2, and so now it's the intercept on the x-axis are minus of half and plus of half instead of the minus of 1 and 1. So 1 becomes now half and minus 1 becomes minus half. Why is it so? Because previously original signal was x of t, and now scaling signal is x of 2t. So now t is replaced by 2t, that is why the intercept is getting half. Similarly, if scaling factor is lies in between 0 to 1. In that case, the signal will stretched in the time. Here, as you can observe in the third graph, if yt is of x of half of t, in that case our signal will stretched, and the intercepts on the x-axis will be 2 and minus 2 instead of the 1 and minus 1. Another case may be possible that if a is less than 0, in that case it will flip in the negative direction. Next is the amplitude scaling. So it will amplify the signal on the amplitude scale, amplitude axis. So for the time being, we are considering the example. You can see the original signal is the first one, and once it will amplify by some factor, let's suppose a, and if the a is greater than equal to 1, in that case the amplification factor will be the higher, and it will increase the amplitude of the original signal. So here 2 of xt, this is the amplified one. Similarly, if a is less than 1 and greater than 0, then the amplitude is decreased, means attenuation in the amplitude. So last graph is representing the half of xt. So here a is equal to half. Similarly, the a may be possible to have the value less than 0. In that case, again, the signal will be in the negative direction. Now, we are going to discuss some operations, that is signal addition. So, suppose if we have the two different signals, x1t and x2t, then if we are adding it, simply we can do it in the arithmetic manner. As for example, if x1 signal is unit step and x2 signal is the unit ramp function, then the addition will be like yt will be equal to 0 for t less than 0, and 1 plus t. 1 will be counted from the unit step and t because of the ramp function. So finally the yt will be equal to 1 plus t for t greater than 0. And so finally the graph is showing that is ramp. It looks like ramp function having the magnitude is of starting from the 1. So it's a simple mathematics. So here now next thing is the signal multiplication. So for two signals x1t and x2t, their products can be given by yt, which is equal to x1t into the x2t. So this is again the simple multiplication. So for the time being, let's consider the one example. So here x1t may be equal to the u of t unit step, x2t may be equal to the r of t, that is unit ramp function. So the multiplication will be equal to the unit ramp function, that is the expression will be yt is equal to 0 for t less than equal to 0 and yt is equal to t for t greater than equal to 0. Why? Because ut is simply equal to 1 for greater than t is equal to 0. So since the ramp function is also lies in between the 0 to infinity only, so before the 0, again the output will be equal to 0, 0 into 0, and unit step have the 1 magnitude. In that case 1 into ramp function will be equal to the ramp only. The major application of this multiplication factor can be utilized in the to modulate the signal in with the carrier. So here the first one is the carrier signal, second one is the massive signals, and the third one, that is your modulated signal. So that in the next session we will discuss the classification of the continuous and discrete time signals, where we'll see the periodic and aperiodic, even and odd, energy and power, and the deterministic and random type of the signals. Thank you for listening. If you have any problem, please comment us. Thank you.